It's a wonderful Saturday morning here in the month of May. And today we're going to go over parabolas. And we're going to focus on when our quadratic formulas or equations are presented to us in standard form and vertex form. So the first two will be standard form, second two will be vertex form. So we know this is in standard form because the formula or the template is y equals ax squared plus bx plus c. And that is the format that we have. One of the first things that we need to observe or recognize is that a is negative. So when a is going to be negative, we can write this. When a is less than 0, our parabola is going to have this shape. It's going to be an upside down. But we should always recognize and label what we have for a, b, and c values. It's just good practice. It keeps it clear. So when we go through our steps in graphing, we know what those things are. So in all of our graphs, whether it be standard, vertex, or even x-intercept, we're going to calculate 2 and we're going to get 3 for free. That's 99.9% of the time. There are very few instances where we have to do a couple more calculations because the vertex is the y-intercept or the vertex is the x-intercept. A couple interesting, weird situations. But in this case, we're always going to start off recognizing what's the shape, what's the overall shape of the parabola. Second is let's label our A, B, and C. And now let's start going through. When it's in standard form, the first thing we're going to find is the axis of symmetry. And the axis of symmetry can be found out. It's a formula. X equals the opposite of B over 2A. So we have the opposite of my B value over 2 times my A value. That gives me -6 over -2, which equals +3. So my axis of symmetry, which is a line, is x equals 3. So if I drew that line x equals 3, it would look like this. And I make it dotted because it's not part of the solutions. I do it because we're going to, the parabola is symmetrical based upon that axis. So that is going to be what I call the mirror. It's the line of symmetry. It's the reflection, line of reflection. All the points will reflect over that line. These are big, important math terms that you should be familiar with going into high school, those terms, reflection. Second point is, or second step is to find the vertex. When we find the axis of symmetry, we know the vertex will lie on it. In this case, because it's upside down, this vertex is actually going to be a maximum point. It's going to be my highest point on the parabola. But we already know the x value of the vertex. And we have to find out what the y value is. So we do that by plugging that x value, 3, into the equation. So we have -3 squared plus 6 times -3, so not 6 times -3, Mr. Max, 6 times 3 minus 8. Now this gave lots of people fits. This is one of those tricky situations. This is your exponent. What is the base of the exponent? The base of the exponent is 3 because we did not plug in -3. X. This is x squared. This is the opposite of x squared. So we're squaring x and then we're taking the opposite value. Totally different from the quantity of -3. So we're going to square 3, which is 9, and then we're going to take the opposite. So we bring down that negative, we square 3. 6 times 3 is 18 minus 6. That's going to give me 9 minus 6, which gives me 3. Let's make sure we wrote down. No, Mr. Mac, I made a mistake already. Gosh. That says -8. Mr. Mac kept writing -6. Oh, I know you said, where did the 6 come from, Mr. Mac? It came from my crazy head. Sorry. All right, so we can fill in that value. So my vertex has an x value of 3, and when you plug in 3, its y value is 1. So 3, 1. 3, 1, we're going to make a dot right there. We're going to label it. That'll be my maximum point, so I'm just going to put it above it because my shape, my tendencies will go down, my points. All right, that's 2. Vertex 3 is going to be the y-intercept. Now this is a freebie. Vertex was a calculated. 3, find the y-intercept. Well, we know that it's always going to equal the c value, which is the c value. And the c value is -8, not 6, -8. So my y-intercept equals -8. So I go to the y-axis, I go to -8, and I have my free point, my first free point, 0, -8. The other thing that we should know about intercepts, a y-intercept, remember x equals 0 in a y-intercept. So if I plugged in 0, and plugged in 0, these values become 0. And that's why I'm left with -8. That's why it's so easy to find the y-intercept, that it's just going to be my c value. Step 4 is to mirror it. Mirror y-intercept. And the way we mirror things is we know it's going to be symmetrical. So they'll have the same distance away from the axis of symmetry. So this is 1, 2, 3 spaces away. So we're going to go 1, 2, 3 spaces to reflect it. And that is going to be my reflection point. That point is going to be 6, -8. So I have 2 points. Now I need a total of 5 points. So I don't have any more freebies. So I'm going to have to pick an x value. The x values that we've currently used, the x values that we've already used are 0, 3, and 6. So I'm not going to pick any of those. I'm going to pick 1, 2, 4, 5, -1. But in this case, I'm going to pick 1 because 1's a pretty simple number. And 5 is calculate. Let's write calculate. Calculate a 4th point by plugging in an x value. So we've used 0, 3, and 6. I pick x equals 1. So we have the equation y equals -x squared plus 6x minus 8, I think is the original equation. -x plus 6x minus 8. And I'm going to plug in 1 for x. So we get y equals the opposite of 1 squared plus 6 times 1 minus 8. 1 squared is 1, and then the opposite, I bring down that negative, plus 6 minus 8 gives me 5 minus 8 gives me -3. So when I plug in 1, I get -3 as my 4th point. 1, -3, 1, -3 takes me here. Let's label it. It is 2 away, so I'm going to go 2 away on the other side, and that is location 5, -3. Remember, these points are based upon, the coordinate is based upon the origin. So we see that I went 1, 2, 3, 4, 5, down 1, 2, 3. So that's how I'm getting that coordinate value. I have 5 points, and now I need to connect the dots. If I don't connect the dots, I've only shown 5 of the solutions. And it says sketch the graph, meaning sketch the solution. So with arrows shows all of the possible solutions for the equation y equals negative x squared plus 6x minus 8. Good? All right. Oh, look at this one. We've already changed it up a little bit. So I know my a value is 1/2. My b value is 0. My c value is 3. B is going to be the coefficient of x. And there is no x value, so the coefficient must be 0. And because my a is positive, I know that when a is greater than 0, I know that my parabola is going to have that shape. Okay? It's in standard form, so we're going to find the axis of symmetry. And the axis of symmetry is the formula x equals the opposite of b over 2a, the opposite of 0 times 2 times a, which is 0 over 1, which equals 0. So my formula is x equals 0. Where is x equal to 0? Right on the y-axis. So my vertex is going to be on the y-axis. Next thing we do is find that vertex. And we find the vertex by plugging in x equals 0 in the formula y equals 1/2 0 squared plus 3. Y equals 1/2 times 0 plus 3. Y equals 0 plus 3. Y equals 3. So my vertex is 0, 3. So vertex 0, 3. Let's write the coordinate 0, 3. And what do we notice? Oh, man. My vertex is also my y-intercept. So that's a bummer. So typically, point 3, or the next point is y-intercept. But the y-intercept is already found. And the other bummer is we used to reflect the y-intercept. So we're missing out on 2 freebies. And no mirror point. No mirror of y-intercept because it lies, it lies, I don't know if that's the proper, it lies on the axis of symmetry. So it won't have a reflection point. So we get to 5 where we're typically looking for a 4th point, but we're actually finding a 2nd point by picking an x. So this time I'm going to say x equals 1. We take the formula y equals 1/2 x squared minus 3. Minus 3 plus 3 plus 3. And we're going to plug in 1. So we get 1/2 1 squared plus 3. Y equals 1/2. 1 squared is 1. 1/2 times 1 is 1/2 plus 3 equals 3 and 1/2. So the coordinate 1, comma 3 and 1/2. Oh man, I don't like fractions. Well, you'll see when we pick our 4th point. So we have 1, 3.5. 1, 3.5 goes up a little bit. That is the coordinate 1, 3 and 1/2. We mirror it, which is negative 1, comma 3 and 1/2. I probably should move that down a little bit. Oh, everything came with it. Oh, this is going to be ugly. Let's do this. Let's do this. Let's move those down a little bit and then draw the dots. There and there. Good. And I did that just because we're going to have our next points. So that was ugly. Well, look at our A. Our A is 1/2. So 6 is mirror. 2nd point. And we're going to have to go to 7, which is find a 4th point. So this time, let's think about not getting a fraction. Well, we're going to square my x, and then I have to multiply it by 1/2. So if I could find, if squaring x can give me a multiple of that denominator 2, that's going to cancel the denominator. So I'm going to do 2. So instead, I'm going to plug in x equals 2, and we're going to see that we get a much better, or no fractions in our solution. 2 squared is 4. 1/2 times 4 is 2, which gives us 5. So when I plug in 2, I get 5. Oh, no fractions this time. Good. So 2, 5 is right here, and negative 2, 5 is going to be its reflection point. 2, 5, and negative 2, 5. All right. Those are 5 points, and I connect the dots. I've labeled them. I can see and read my coordinates, and that's good. So this one actually took 8 steps because you're going to mirror 4th. So that happens sometimes where your vertex is your intercept. So be aware of that. Okay. Hopefully that you got those right. You understand it. Let's talk about the vertex form. So vertex form, again, has a template, very much like standard. Vertex form is y equals a. I'm not 100% certain that that is a in front of there. I'm pretty sure it is. But it is y equals a times the quantity x minus h, quantity squared plus k, where your vertex is h comma k. Notice this h is positive, this h is negative. So whatever you see here is the opposite of your h value. So you can't get tricked by that. Your k value is straight up. Your k value is going to be whatever that constant outside there, outside of the parentheses. So the first thing, this time, we're going to get 2 free points, or we're going to get 2 calculated points, and we're going to get 3 free points. The nice thing about vertex form, and we don't look for A, B, and C here. It's not in standard form. What we're doing here in vertex form is pulling out the vertex. So the vertex is going to be the first thing we do. Find the vertex, and that vertex is going to be the opposite of whatever I see in the parentheses. So 1, and then comma negative 1 is my vertex. So 1, negative 1 is going to be my vertex. Now, the cool thing about that, other thing we should notice is we have that negative outside there. So that negative outside there, let me see for a second. I don't know if we did negative. It's going to be interesting whether that was in the problem. I know it's a distraction. I'm sorry. Let's just be patient for a second. Mr. Mac wants to. Let's save this real quick. Detailed answer. Let's do this. I want to pull this back up because I resized this, and in resizing, I maybe uncovered the negative that I covered. Let's see. Oh, no. Okay. Nope. There was a negative there. Okay. So we're good to go. So we see that A is negative. Let's not do yellow because we already have yellow for the H. Let's do purple. My A value is negative. So I know that my parabola is going to be upside down. And that's good just for having a good idea of where your next points should be. Are they reasonable? Are they in the place that makes sense? So the reason why I'm going to put that, I'm going to label that point with the coordinate above it because the shape's going to be upside down. So we found the vertex. The cool thing about finding the vertex is we know the axis of symmetry also lies on that vertex. So that's my reflection point. Second thing here is find y-intercept, but this time it's not free. This time we have to utilize the fact that we know that all y-intercepts have an x value of 0. So we're going to take this equation, we're going to plug in 0 in for my x, and we're going to simplify. Ooh, notice this one too. This time we see our exponent is 2, but this time our base is -1. So we're squaring -1, and this negative is different from the negative inside it. So we're going to square -1, which is 1, and then we're going to pull down this negative, and we get the -1 over here, so we get -2. So my y-intercept is 0, -2. Does that play into which shape that I was expecting? Yep, it does. I knew the parabola was going to be upside down. So we can plot this point also, the mirror point, and that would be 3 is mirror the y-intercept. 4 is find a fourth point. So I have to pick a different x. I've used 0, 1, and 2. So I'm going to say x equals, let's do 3. Let's do 3. Y equals the opposite of the quantity, 3 minus 1 squared minus 1. We get 3 minus 1 is 2. Notice the parentheses. I'm squaring 2 and then taking the opposite value of that. So we get -5. So when I plugged in 3, I got -5. 3, -5, 3, -5 is right there. That's nice. That looks good. 2 away, 2 away. That point is -1, -5. So look how fast we were able to graph that parabola. All the solutions of that parabola. Good? All right, vertex. Ooh, so this value is going to be the opposite of what I see for my x value. And what do we notice? We don't have a k value. K is not there. So my vertex is going to be -1, the opposite of what I see, and then 0, because there is no, that's kind of like +0 in our head. So -1, 0. -1, 0 is here. My a is positive, so I know it's going to go up. So I will label my point underneath there. My y-intercept, I'm going to plug in x equals 0. We get y equals 1/4, 0 plus 1. We don't have to plus 0 because technically it's not even there. So that would just be 1/4 times 1. Y equals 1/4. Whoa, 0, 1/4. Yuck. Yucky. 0, 1/4. Okay. I forgot to draw my axis of symmetry, which was on my vertex because I got my vertex. And then we plot this one, which is, so this is 0, 1/4, and this is going to be -2, 1/4. All right, I mirrored. This is my y-intercept. I mirrored my y-intercept. And 4 is find a fourth point. Find fourth point. So what value do I want to come out of that squared? Well, I want a multiple of 4. So if I pick x equals 3, that would be good. If I picked x is -3, that would be kind of crazy. But let's pick 3. Let's keep it relatively straightforward. X equals 3. So we get y equals 1/4 times the quantity, 3 plus 1, quantity squared. Is that correct? Did I write that? Plus 1, quantity squared? Yep. So I get 1/4 times 4 squared. We have to square before we multiply. Don't multiply 1/4 times 4. You have to do exponents before multiplication. So that's 16, and we get 4. So when I plugged in 3, I got 4. That's a nice clean one. 3, 4 is way over here. 3, 4, and then it's 1, 2, 3, 4 away. 1, 2, 3, 4 away. So don't go off the axis of symmetry, not the y-intercept, or not the y-axis. So that takes me to -5, 4. And I got that, and I got that. All right. That wasn't too bad. Hopefully you do enough of those where you see all the different instances. So come and see me if you have questions.